Solving right triangles. Every right triangle has one right angle, two acute angles, and one hypotenuse and two legs. To solve a right triangle means to find the measure of all 6 parts. You can solve right triangle if you know either of the following: 2 side lengths, 1 side length, and 1 acute angle measure. So if you have any of these, you can actually solve. And when you're solving it, you are solving all 6 parts, okay? So solving for angles, inverse trigonometric ratio. If you know the sine, cosine, or tangent ratio for an angle, you can use an inverse to find actual measure of the angle in your calculator. So if you look at your calculator, you're going to have sine, but you're also going to have sine to the -1 power. We call this, when you see the -1, we read this as the inverse sine of x. So this is called inverse. So the inverse of sine x, this is sine angle equals x. This is measure of angle sine, is inverse sine of x. So this means inverse. So if you want to solve for angles, you're going to use x is measure of angle, inverse sine of x, inverse sine of cosine, inverse sine of tangent. If you put the ratio for x, y, z, it will give you the angle measurement. So we're going backwards. We went from angle to ratio, now we're going from ratio to angles. So we're going to find all 3 sides, and then we're going to find all 3 angles. So this is just for the right angles. So it says, given 2 sides and no acute angles, solve the right triangle. So this is 90. So we're just doing right triangle. And sine, cosine, tangent is only for right triangles, right? We want to find the angle A, angle B. And we want to find, we have 8 and 10, we want to find this. So in order to solve triangle, you need all 3 sides measurement and all 3 angles. We already have 90, so you need the other 2 angles. So in order to find C, C is always across from hypotenuse. This is C. So you're going to do Pythagorean theorem. A squared plus B squared equals C squared. So let's write this down. A squared plus 10 squared plus C squared, 64 plus 100 is C squared. Square root of 164 is 2 radical 41. So this is 2 radical 41. Now we're going to find angle measurement. We're going to use tangent to do that, and let me show you why. If I want to find angle A in a right triangle, this is hypotenuse, right? I have opposite over adjacent, right? Adjacent means next to the angle. Opposite is across from the angle. So it's 10 over A, because TOA is the ratio. So 10 over 8. And if I put this ratio using inverse tangent function on the calculator, it will give you the angle measurement. So let me show you. Everybody go to Desmos. We're going to click on this button right here. After you click on this button, you're going to put 10 divided by 8, and that's the ratio, and this gives you the degree, the angle measurement of the ratio that you put in. This is opposite over adjacent, 10 over 8. So it's 51 degrees. So everybody try this on Desmos, please. So 51 is the angle measurement here. So you can just do 180 minus 90 minus 51, you can get 39. You can just subtract and get the remaining measurement. Or you can do also tangent, 8 over 10 for this one. So if you do 8 over 10, go here, click on this, and then the 8 divided by 10. Oops. You get 8.6, which is 39. So here you can get that using tangent. Okay? So now you have 90, 51, 39, 8, 10, and 2 radical 41. And instead of 2 radical 41, you can just do 2 radical 41, you can write 12.8. Okay? All right, so let's continue. So we want to find the solve the right triangle. When I say solve right triangle, which means I want all three angles, all three sides. So we're going to find 4, 5, and C. We don't know C. So 4 squared is 16. 5 squared is 25 equals C squared. We're going to do square root of 41, which is the answer for C. And then we want to find this angle and then this angle. So once we find 1, we can add 90 and subtract from 180 because triangle is 180. So what we're going to do is, from this angle, looking from here, you have opposite over adjacent, 5 over 4. So you go to decimals, you're going to type inverse of tangent, which goes from ratios to degrees. And then we're going to type 5 over 4. 5 divided by 4. Please try it on your decimals. And then 51 degrees. So we're going to use 51. So once you have 51, 51 plus 90, subtract from 180 is 39. So you get the third angle. I want you to go ahead and solve this for me. Find X and find one angle and then find the other one. So go ahead and do it right here, please. Let's look at example 4. Give one acute angle and one side, solve the right triangle. So here we have 20 degrees, 90 degrees. This right here will be 70 because 90 plus 20 subtract from 180, that's 70, right? So we got all three angles. Now we need all three sides. You have 15 here. We don't know this. This one is 5. We don't know R. This one's S, I'm sorry. This one is S, this one is R. We need to find this side and this side. So we're going to use sine, cosine, or tangent to do that. So once angle's given, you're going to use the ratio, okay? So what we're going to do is look at this angle. You have opposite over hypotenuse. That's SOH. You have to remember that. SOHCAHTOA, okay? SOH means opposite over hypotenuse. This is always hypotenuse, 15. So you're going to write sine 20 equals R over 15. Now put over 1, cross multiply. So 15 sine 20 equals R. And then we're going to put that on decimals. So let's do that. So go to decimals and type 15. And then type sine 20. And then you get 5.13 and change. So we're going to write 5.1303. So that will be R here. Okay? So use 4 digits. We usually use 4 digits for this. And then now we're going to find this side. So you're going to use the same angle, 20. And we're going to go to find S, you need to include S on the ratio. So you're going to solve for S. So you're going to have adjacent over hypotenuse, CAH. So adjacent over hypotenuse, you have to remember the ratio. And then what we're going to do is put it over 1, cross multiply. So cosine 20 times 15. So we can do 15 cosine 20 or cosine 20 times 15. So you can put parentheses around cosine. If you're going to do cosine 2015, put parentheses around this and then multiply by 15, okay? Then you get 14.09. So here, 14.0954. So that's this side right here. So now we have all three sides and all three angles. That's how you solve right triangle. let's take a look at this one. We have, let me make this bigger. We have this angle, this side. We don't have anything else. We have B and C, and then we have to find this. So this angle is easy. 52 plus 90, subtract from 180, you get 38 for that. So angles are taken care of, but we need to find B and C. Now you cannot use Pythagorean theorem because you're missing two sides. So we're gonna use sine, cosine, or tangent to do that because you got an angle here. So you're gonna do 52. If you wanna find C, you're gonna do 52. What you're given is adjacent over hypotenuse. That's CAH, adjacent over hypotenuse. So hypotenuse C, so we gotta include that. We're looking for C. So we're gonna do 19 over C. So write cosine 52 equals 19 over C. So this is the ratio for cosine, right? A and H. This is the adjacent, that's the H, hypotenuse. So we're going to cross multiply. So we're gonna do C equals 19 divided by cosine 52. If you do that, you get 30.8611. And if you want to find missing B right here, use the same angle. We're going to do opposite, which is here, over adjacent. Opposite is right across from the angle B over 19. So we're going to do tangent 52 equals opposite over adjacent ratio. So it's going to be B over 19. And then cross multiply, so do tangent 52, put parentheses, and then times 19. Or if you write 19 first and do tangent 52, that's okay. But if you write tangent 52 times 19, you gotta put parentheses around this because the calculator is gonna do 52 times 19 first. Then that's tangent of something bigger, right? So you have to separate and put parentheses here if you wanna do tangent 52 and then times 19. And if you do that on the calculator, you get 24.3189. So these two are B and C. So now we solve all three angles, all three sides. So what I want you to do is do this as an exit ticket, and I want to check it. So when you're done with this, use your notes and solve this side. Give me two angles for this triangle. Give me this angle and give me the other two missing sides. So I need all three sides, all three angles, all three sides, all three angles. Just write the missing measurement on this triangle when you're done, and use cosine and sine and tangent to do that, or Pythagorean theorem. So please do this right now. Write your name. I'm going to collect it and check it. Please use your notes.